This is Spacetime Series 27, Episode 41, for broadcast on the 3rd of April 2024. Coming up on Spacetime, a new study that shows how Scandinavia was actually born in Greenland. Blue Origin's planned orbital reef space station passes an important milestone, and the growing role of space in monitoring climate change. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
A new study looking at the oldest Scandinavian bedrock has found that it actually originated in Greenland. The findings, reported in the journal Geology, help scientists understand the origins of continents and why the Earth is the only planet in our solar system to harbour life. The key was uncovered in a Finnish outcrop nestled between some of Northern Europe's oldest mountains. There, geologists found traces of a previously hidden part of Earth's crust that points back more than 3 billion years in time and west towards Greenland. The evidence was actually found locked in the mineral called zircon, which, after chemical analysis, showed that the formation upon which Denmark and Scandinavia rest was probably born from Greenland some 3.75 billion years ago. One of the study's authors, Todd Wright from the University of Copenhagen, says the data suggests that the oldest parts of Earth's crust beneath Scandinavia originate in Greenland and is about 250 million years older than previously thought. The author's study of the zircon showed that in several ways its chemical fingerprints match those of some of the oldest rocks on the planet, which were found in West Greenland's North Atlantic craton. Wright and colleagues say that the zircon crystals, which were found in river sand and rocks from Finland, have signatures that point towards them being much older than anything else ever found in Scandinavia, while at the same time matching the age of Greenlandic rock samples. And the results of 3 independent isotope analyses confirms that Scandinavia's bedrock was most likely linked to Greenland. Denmark, Sweden, Norway and Finland rest on top of a part of the Earth's crust known as the Fennoscandian or Baltic Shield. The authors believe that it broke away and shifted for hundreds of millions of years until it eventually took root where Finland is today. Here, the plate grew as new geological material accumulated around it until it eventually became Scandinavia. Now, at the time of this tectonic plate's detachment from Greenland, the planet looked very different to what it does today. Wright says the Earth was probably a watery planet, but without any oxygen in the atmosphere and without any emergent crust. The fact that the Earth even had a continental crust composed of granite is quite special when you look into space and compare our planet with other planets. Having a tectonic plate system with continental granitic crust is unique in the solar system. And evidence of liquid water, as well as a granite crust, are key factors when trying to identify habitable worlds and the possibility of life beyond Earth. This new study adds fresh pieces to a primordial continental puzzle that began long before life on Earth truly blossomed, but which largely paved the way. Understanding how continents formed helps scientists understand why Earth's the only planet in the solar system with life on it. That's because without fixed continents and water in between them, life couldn't have evolved. Indeed, continents influence both ocean currents and climate, which are both crucial for life on Earth. The authors say their findings contribute to a growing number of studies which have rejected the means used so far to calculate how continents have grown, especially during the first billion years of Earth's history. The most commonly used models assume that Earth's continental crust began to form when the planet was formed 4.6 billion years ago. But instead, several recent studies have suggested that the chemical signatures showing the growth of continental crust can really only be identified about 1 billion years later. Wright says the new results add to previous research that found similar seeds from ancient crusts in other parts of the world. It provides another important clue in the mystery of how continents formed and spread across the planet, especially in the case of the Fennoscandinavian Shield. But of course, there's still plenty science doesn't know. In Australia, South Africa and India, for example, similar seeds have been found, but the authors are unsure as to whether or not they come from the same birthplace, or whether they originated independently of one another in several different places on Earth. This is Spacetime. Still to come, engineers working on Blue Origin's proposed orbital space station pass a major milestone, and we look at the growing role of space in monitoring climate change. All that and more still to come on Space Time. Scientists and engineers working on Blue Origin's Orbital Reef commercial space station project have completed a major testing milestone for the Future Orbital Outpost Crucial Life Support Systems. It's one of 4 milestones needed to be met under NASA's Space Act agreement, which is funding the project. The objective this time focused on the materials and designs for systems to clean, reclaim and store the air and water crucial for human spaceflight. The joint Blue Origin Sierra Space project is being designed to support 10 people in modules totaling some 830 cubic meters of volume, which could be operational as soon as 2027. The current International Space Station has modules totaling just over 1,000 cubic meters of living space. The milestones being set by NASA are crucial for ensuring that any future commercial space station can support human life. NASA wants these commercial space stations to be operational so they can continue having access to low Earth orbit space for conducting important scientific research once the existing International Space Station reaches the end of its operational life sometime around 2030. Each completed milestone allows NASA to gain insight progress on the new station's design and development. On the current International Space Station, components for the environmental control and life support systems maintain clean air and water for astronauts. The regenerative system recycles and reclaims most of the water and oxygen produced by normal human activities. And yes, that really does include drinking water recycled from urine and sweat. Of course, it is all purified and disinfected before it reaches your lips. And importantly, it significantly reduces the amount of additional payload that needs to be flown up to the space station on supply missions. The new Orbital Reef space station will have a similar system in place. All 4 milestones are testing different parts of the system, including a trace contaminant control test, a water contamination oxidation test, a urine water recovery test, and a water tank test. The Trace Contamination Control Test screens materials to remove harmful impurities from the air. NASA is currently supporting the design and development of multiple commercial space stations, including Blue Origin's Orbital Reef. This is Space Time. Still to come, the growing role of space in monitoring climate change. And Dragon delivers more supplies to the International Space Station. All that and more still to come on Space Time. A new report from the World Meteorological Organization has confirmed that climate change has smashed all previous records for greenhouse gas levels, surface temperatures, ocean heat and acidification, sea level rise, Antarctic sea ice coverage, and glacier melting and retreating. The study shows that 2023 was on average some 1.45 degrees Celsius above pre-industrial baseline levels. Scientists found that glaciers suffered the largest loss of ice on record, and Antarctic sea ice was some 1 million square kilometres below the previous record lows for summer. Well, much of the data supporting this new study was based on direct observations taken at weather stations around the planet. An increasing amount is being gathered by weather and environmental satellites orbiting the Earth. And the European Union's constellation of Copernicus Sentinel satellites makes up the largest single fleet of climate change monitoring spacecraft in existence. The Sentinels provide systematic data for environmental services that will help people adapt to the worsening change. This report from ESA TV.
All over Europe, climate change is a growing concern, with global sea levels rising between 16 and 20 centimetres since 1900. Climate change is undeniably having an effect on oceans, land surfaces, ice caps, and weather patterns across the globe. It is well understood that climate change is caused by atmospheric gases such as carbon dioxide and methane. When we look at these trace gases, there is an obvious correlation between human activity and climate change.
CO2 concentrations of the atmosphere over the last 800,000 years. These values are going up and down in different phases. Over the last 800,000 years, the value was always below 300 parts per million, and suddenly, since the last century, it goes up very steep towards 400 parts per million or even beyond. And this is what we have today. This is the increase of carbon dioxide drastically increasing over the last 100 years caused by human beings.
In order to tackle climate change, scientists and governments need reliable data to understand how our planet is changing. This can be provided by ESA, which monitors our planet from space. With EU Copernicus Sentinel missions and Earth Explorer missions in orbit, ice thickness and coverage, deforestation, soil moisture, sea level and ocean surface temperature, as well as other essential climate variables, can be measured. These satellites have global coverage, revisiting the same region every few days, therefore providing a good understanding of the health and behaviour of our planet and how it's affected by climate change. In turn, this offers decision makers key information for mitigating strategies and policies.
Frequency and consistent observations of our environment are very important if we want to give decision makers the key into their hand on where humankind has to change practices, where we have to be mitigating for encroaching impacts on our environment.
Satellites can show us how the world has changed. Like in the Camargue, France, where the coastline has retreated more than 200 meters in the last 20 years. In the 1980s, seawalls were constructed here in a failed attempt to stop the rising water. Back then, sea level was rising, but more slowly than it is now. Over the last 5 years, records show that the rise in sea level is accelerating. Soon, part of this delta will be lost to the sea. And what is happening here is happening in many parts of the globe. Worldwide, more than 370 million people live less than 5 meters above sea level. Over 100 megacities such as New York or Tokyo are near the water. All are at risk. Satellite data gives us the facts so that we can prepare ourselves for the rising tide and protect coastline populations. This data is also used in ESA's Climate Change Initiative, where ESA scientists preserve and work with long-term datasets going back to 30 years and more to get an even better understanding of climate change. Thanks to satellites, we have evidence that the planet is in danger. Now it is up to people on Earth to take the necessary measures in time. The key for sustaining life on Earth might come from space.
And in that report from ESA TV, we heard from Josef Aschbacher, the director of ESA's Earth Observation Programs, and Michael Rass, ESA's Earth Observation Senior Advisor. This is Space Time. Still to come, SpaceX's Dragon delivers more supplies and scientific equipment to the International Space Station. And later in the science report, the new implantable battery that uses the body's oxygen to deliver a stable electrical supply. All that and more still to come on Space Time. Critical new scientific experiments and technology have arrived aboard the International Space Station as part of NASA's latest commercial resupply mission. The SpaceX CRS-30 mission docked to the Harmony Zenith port aboard the orbiting outpost 2 days after launching from the newly reconfigured Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida. It was the first flight to use the upgraded launch pad, which has been equipped with a new crew access tower and arm, allowing it to be used for manned space missions.
For our growing launch manifest, we've made new upgrades to Space Launch Complex 40, including a brand new tower and access arm, which enables more efficient late load operations as well as human spaceflight missions. Now, with these updates, we are on our way to having 2 launch pads capable of supporting flying humans to space.
Stage 2 locks load complete.
With Stage 2 locks load complete, that gets us inside the 2-minute marker to countdown. Checkouts on the second stage thrust vector control have passed. We'll get to engine gibbling and wiggle test on the first stage much closer before ignition. At the time of launch, the International Space Station will be flying 260 statute miles over the border of Mexico and Guatemala.
Falcon 9 is in startup.
We are now in startup.
Dragon is in countdown.
And Dragon is in countdown. Range remains go for launch, waiting for that final go from the SpaceX launch director.
SpaceX launch director, go for launch.
You heard that call out. The launch director has given that final go. All systems are go for launch of Falcon 9 and the CRS-30 mission.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff as Dragon returns to Stage 1 Complex 40.
3 tons of science and cargo take flight on NASA's SpaceX 30th Commercial Resupply Services mission. Falcon 9 at 1.7 million pounds of thrust, pitching down range, hearing good calls of performance. Nominal trajectory as Falcon 9 and Dragon arc out to the northeast.
Falcon 9 has successfully lifted off from Slick 40 at Cape Canaveral Space Force Station. And during ascent, we will tilt or gimbal our engines, guiding the rocket into what we call a gravity turn. Through this turn, the vehicle is flying both up and horizontally away from the launch pad. Now, this rocket typically needs to go about 17,500 miles per hour horizontally in order to make it to orbit and avoid being pulled back down to Earth. So moments ago, we did throttle the engines down in preparation for max Q, or maximum aerodynamic pressure, in just a couple seconds.
Max Q.
There was that call out for max Q. And coming up, we have a few events in quick succession, starting with main engine cutoff, followed by stage separation, second engine startup 1, and the start of the boost back burn for the first stage.
MVAC is chilling.
There's the call out. The MVAC engine on the second stage is chilling in, getting ready for startup. Now, the first of these events is main engine cutoff, or MECO, where the 9 Merlin 1D engines on the first stage will shut down in preparation for stage separation, which is where stage 1 and 2 will separate from each other, with the first stage making its way back down to Earth and the second stage performing second engine start 1, which is where we ignite that single Merlin vacuum engine on board the second stage. Now, the boost back burn will then start on the first stage. This burn helps assist the vehicle flip back around and reorient itself back to land.
MECO.
Stage separation confirmed.
MVAC ignition. Stage 1 boost back startup.
There you heard those events happening back to back. Again, we had main engine cutoff of the first stage, stage separation, second engine start on the second stage, and that first stage doing the awesome flip as it starts its boost back burn. Now, this burn is a little under a minute, so we have about 20 seconds left in this burn. And about 3 minutes after that, we will have 2 additional burns on the first stage to prepare to land back at landing zone 1 at Cape Canaveral. We are at T plus 3 minutes and 30 seconds here in today's mission. CRS-30 is SpaceX's
Stage 1 boost back shutdown.
There is that confirmation for the boost back shutdown of
Both
the first stage.
Nominal trajectory.
And a nominal trajectory. As again, CRS-30 is SpaceX's 27th launch this year, and we are coming up on the entry burn of the first stage as well as second engine cutoff. And around T plus 6 minutes and 30 seconds, you should see the first stage's entry burn. And for the entry burn, we relight 3 of the M1D engines on the first stage, starting with the center engine 9, followed shortly by engines 1 and 5, which slows the vehicle down as it passes back into the Earth's atmosphere. We need to slow down to reduce re-entry forces, which helps us to recover and reuse the first stage and second stage, and that Merlin vacuum engine heating up as it performs its burn. 4 hypersonic grid fins deployed, helping steer that first stage down as it makes its way back home to Earth. Just about 20 seconds from the start of our first stage entry burn.
Stage 1 entry burn startup.
There is the start of the stage 1 entry burn, and this is a 3-engine burn on the first stage of Falcon 9.
Stage 1 entry burn shutdown.
TS has safed.
And
both
the flight
stages, nominal trajectory.
and the call-outs for nominal trajectory and the flight termination system being safe. Now, the first stage that is supporting today's mission has just performed this entry burn for the 6th time. Falcon 9 is the world's first orbital-class reusable rocket, and this allows SpaceX to refly the most expensive parts of the rocket, which in turn drives
Stage 1 transonic.
down the cost of access to space. Now, coming up, we have that landing burn starting in just a few moments. There's the start of
Landing burn.
start of that landing burn.
Stage 1 landing leg deploy.
Wow, that first stage
Stage 1
landing.
landing confirmed.
Back at landing zone 1, that landing marks SpaceX's 286th recovery of an orbital-class rocket, including the first stage landings for Falcon
Stage
9
2 FTS has safed.
and Heavy. You heard that call out that Stage 2 FTS is safe, getting ready for second engine cutoff.
MVAC shutdown.
There is that second engine cutoff with the MVAC shutdown call out, waiting for confirmation of a good orbital
Nominal
insertion.
orbit insertion.
There is that confirmation of good orbit. It looks like we are on track for Dragon separation in just a few minutes, just before the T plus 12-minute mark. It has been a great launch so far. As I mentioned earlier, today's launch was the first for our upgraded Dragon to be flying from Slick 40 after we stopped flying the older version of Dragon back in 2020. And in addition to flying cargo to support crew on board the space station, SpaceX also enables researchers the opportunity to fly critical science to orbit on Dragon, which has carried over 1,000 research experiments to and from low Earth orbit and the International Space Station since 2012. Enabling research in space paves the way for us to explore beyond Earth and make life multiplanetary. And now we are waiting for Dragon to separate from Falcon 9's second stage. And for those of you following along, this Dragon capsule has also supported CRS-22, CRS-24, and CRS-27, which were 3 additional cargo resupply missions to the International Space Station. At about T plus 8.5 minutes, we had a successful second engine cutoff, followed by confirmation of a good orbital insertion. The vehicle is now coasting with Dragon attached, and we are just about 30 seconds away from spacecraft separation. Dragon floating away there. Dragon is drifting away from Falcon 9's second stage there, confirming good spacecraft separation.
The Dragon capsule fitted aboard the Falcon 9 rocket was loaded with more than 2.7 tons of supplies and cargo. The payload included advancing studies crucial for understanding sea ice dynamics and for facilitating plant growth in microgravity. Also included in the manifest was the joint CSIRO-Boeing project to test the ability of a multi-resolution scanner to create three-dimensional maps of the space station. This new technology will be used by the Astra-B robots to enhance their own three-dimensional sensing and mapping capabilities for autonomous operations. And not just aboard the International Space Station, but also for use on future Artemis lunar missions and for the soon-to-be-built Lunar Gateway space station as well. Also aboard the CRS-30 mission was a new BurstCube compact satellite. It's designed to observe gamma-ray bursts, the universe's most powerful and energetic explosions. These blasts, which are the most powerful since the Big Bang itself, typically occur during neutron star collisions. BurstCube will be launched from the space station and expand science's observational capabilities to study these extreme events, improving detection through both electromagnetic and gravitational wave signals. Dragon also carried equipment for the Genomic Enumeration of Antibiotic Resistance in Space, or GEARS initiative, which is aimed at identifying antibiotic-resistant microbes aboard the space station. Through in-flight gene sequencing, this project will explore bacterial adaptation to space conditions, yielding insights which will be crucial for astronaut health on extended missions and for developing preventative strategies. Also aboard was Redwire's Pharmaceutical in Space laboratory platform. It's designed to crystallize organic molecules in microgravity, which could lead to improved therapeutics to treat an array of illnesses and conditions. Other equipment was supplied by the National Stem Cell Foundation to continue to examine mechanisms behind neuroinflammation, a common feature of neurodegenerative diseases, using three-dimensional brain models derived from induced pluripotent stem cells of patients with Alzheimer's and Parkinson's disease, as well as primary progressive multiple sclerosis. Meanwhile, Airbus US Defence and Space have supplied an enhancement for the space station's Bartolomeo external platform called Argus. Argus will host multiple payloads, including Space TV 1, an optical video system designed to live stream high-definition views of the Earth and the space station. There's also a project from the University of Connecticut designed to examine producing nanomaterials in microgravity, which could help repair cartilage and reduce joint inflammation, significantly improving patient care for orthopedic injuries and degenerative joint diseases like arthritis. Another experiment will test novel gene therapy proposals designed to prevent and possibly even reverse vision loss from age-related macular degeneration. And there's also a project to leverage the microgravity environment to validate an automated tumour-on-chip system that grows patient-derived cancer cells to test chemotherapy drugs. And they're just some of the 250 experiments currently being carried out aboard the International Space Station. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Implanted medical devices all rely on batteries which eventually run low and require invasive surgeries to replace. Now, to solve this problem, scientists have just successfully tested a new type of battery which uses the body's oxygen to deliver a stable power supply. The findings, reported in the journal Chem, claim the current design can produce enough power to run a device like a pacemaker, but the authors hope that this will soon follow on now that they've shown it's possible. A two-legged biohybrid robot which uses muscle tissue to improve movement has been developed by Japanese scientists. A report in the journal Matter claims the new robot is designed to mimic human walking. It operates in water with a foam buoy on top and weighted legs to help it stand upright. Made mostly from silicon rubber that can bend and flex, the robot also has lab-grown skeletal muscle tissue, which is attached to the rubber in each leg. By zapping the muscle tissue with electricity, the researchers were able to make the robot walk, turn, stop, and even make fine-tuning motions. A new report warns that Google has interfered with elections in the United States on at least 41 occasions since 2008. The findings by the Media Research Center also claim Google's new AI tool Gemini won't answer negative questions about Democrat President Joe Biden. The study claims Google's algorithms likely shifted at least 2.6 million votes to Hillary Clinton during the 2016 presidential election. The authors claim the tech giants admitted publicly that it uses its great strength, resources and reach to advance its own values. The report also cited research by AltSites researcher Robert Epstein showing that Google's results and get-out-to-vote reminders favoured Democrats and shifted the 2020 presidential election results by at least 6 million votes. Google has strongly denied the claims. Samsung have started rolling out updates to allow some older cell phones to provide some of the features available through AI compatibility. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The Samsung Galaxy S23 range is now starting to get the One UI 6.1. And this is the version of the Samsung operating system that will give the Samsung Galaxy S23 range, as well as the Fold 5 and the Flip 5, a number of the same AI-enhanced features that the Galaxy S24 range came with as standard. Things like translating languages in phone calls, being able to use the voice recorder to convert voice to text and automatically summarize things, and a number of the AI features inside of the photo editing, photo viewing gallery. So this was announced that those features would be coming to some of the older Samsung devices, but it's taken a few months since the launch, and it won't be available for everyone around the world at the same time. It'll sort of be a staggered rollout. But if you've got a Samsung Galaxy S23, one of the models or one of the recent Fold 5 or Flip 5 models, then you should start to see some of those AI features being rolled out, and I'm sure the operating system will want to tell you about it when the update's done, and you can try them and see what they're like for yourself.
The other big news, I guess, is how many Aussies are are hoarding old phones.
Yeah, well, according to the Australian Mobile Telecommunications Association, which runs the mobilemuster.com.au website, they're saying that there are approximately 22 million phones sitting in drawers, of which 14 million of those are not able to be turned on or updated anymore because they're just too old. And apparently a lot of men are worried that the phones cannot be wiped anymore, even though there are instructions at the Mobile Muster website on how to wipe your iPhone or Android. But the Mobile Muster people are saying that, look, even if you can't turn your device on anymore, we will make sure that the data is wiped, especially when it gets recycled. It's not going to be sort of switched on and have all that information pilfered. So you can recycle the older phones. The precious metals in there can be recovered. And if you have an older phone that's sort of 3 or 4 years old, you're not using anymore, and you're sort of keeping it as a spare, I mean, you can actually still sell those as a refurbished device. They can still be used by somebody else in your family, or you can sell it on Gumtree or somewhere, as long as you've wiped it of all your personal data. So the problem is that people have 3 or 4 different phones in their drawers, no longer useful, and those phones are hoarding precious metals that can go into new phones. So definitely you can go to mobilemuster.com.au in Australia, find where you can drop them off, but any phone store will take your older phones and even things like old routers and make sure that they're recycled.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.